In this video, I'm going to build the spectrum of the LED graph in responding to the wavelength. And I'm first of all, I've had to build the circuit of each of the LEDs. They are clear, they are green, clear red, clear blue, white, and clear green, and also blue. So there's so many LEDs to build the spectrum. And this is the diffraction grating. I bought it from China 2 years ago, maybe, or 1 year ago. 1 year ago, I bought it around $5. And this is a diffraction grating with 600 lines per millimeter. It is around the CD diffraction grating or line. CD is around 625. So this is the image I am trying to get of each of the LED. I'm trying to set the exposure as low as possible to get the image not to overexpose in the zeroth order of the LEDs, and each of the LEDs, as you can see, it gives off the spectrum, different color of light in the first order of diffraction grating, of diffraction pattern. And I take it into the Photoshop and analyze each of the of the of the spectrum of the LED or the diffraction pattern, and trying to align it and trying to find the domain where the spectrum exists, and trying to get the range of pixel. And I'm trying to do now is trying to measure from the origin of the image the length where I can crop each of the pixel, each of the spectrum, and trying to analyze them separately. I'm not really sure how to analyze them all together at once, so I'm trying to analyze them separately and building the graph of each individual spectrum in responding to the wavelength, what I'm trying to do. At first, I'm going to open the Google Colab. We need the knowledge of coding, because if I measure the RGB value in responding to the pixel in the image using the Photoshop, it would take years for this whole image to be processed and get the data. So I have to do it in a faster way using the Google Colab or Python programming language in order to do it. So now I'm trying to crop each of the images according to each of the spectrum. So clear red, blue, and whatever it is, clear blue and clear green and white. So I'm trying to get the RGB value right now from each of the spectrum that I have cropped from the Photoshop, not Photoshop, from the Python coding, from the Python code, using the data that I got from the Photoshop. So I'm trying to get the RGB value. I'm trying to plot now each of the spectrum. So this is the first one is green, it's blue, green, white, clear green, red, and red and maybe yellow. I'm not really sure about that, or maybe the clear green and also the clear blue. So there's so many things. I forget. And now I'm trying to get at least the formula to get, in order for me to be able to get the wavelength of each of the spectrum from the image. So I'm trying to change or convert the wavelength, because at first I plotted against the x-axis, not the wavelength axis. So the x-axis is the pixel axis. So I'm trying to convert from pixel to the wavelength, and after that I'm trying to crop the data just to get only the first order and ignore the zeroth order or the mid order. So now I'm trying to do some coding, and with many errors along the way, because I'm a starter to the programming language, especially the Python. And and this is how I do it. And I'm trying to do it with PyCharm, because at the end I can save the image in a very high resolution one. I'm not really sure. I just set the DPI to 1000. Normally I see on web they just set DPI to 300, but I set DPI to 1000, and it gives a very high quality image. I think better than 300 for sure. So this is the spectrum of the blue LED. It is not a clear blue, it's just a blue LED, and it peaks at around 460 or so. And as you can see, the max pixel value is 0.8, and this is for the blue. And I think the peak have been shifted because of the filter inside the camera that is designed to represent our eyes perspective, our human eyes perspective. So that means the green one is very sensitive. The sensor is very sensitive to the green one, just like our eye. Our eye has a sensitivity. The peak sensitivity of our eye is to the green, which is around 550 nanometers. So this is the green, clear green, the clear green spectrum. It is a little bit broad. I'm not really sure why. You will see comparing, it is a bit broad comparing to the green, just the green, not the clear green. And this is the clear white LED. It's composed of a very well-defined blue peak and also the green peak, which is our max sensitivity of the eyes, and also the yellow peak around less than 600 nanometer. So it comes from the ultraviolet and the yellow of the yellow phosphorus. And this is the clear blue. The clear blue is very dim. I don't really know why, because of the filter of the camera for sure, because as you can see, the pixel value, the max pixel value is around 0.25 comparing to the clear green, which was around 2, I think. So it is very sensitive in the green and not sensitive in the blue, especially close to ultraviolet. And this is the red LED spectrum. It is a little bit weird to see the red LED spectrum is around 610 nanometer peak. And yes, as you can see, it is not really into the red one. I'm not really sure why. Maybe some error in the calculation, or maybe it is just the way it is because of the red filter of the end of the spectrum. So maybe they're trying to cut out the red light as much as possible in order for make it match our eye perspective. So that's why the red one has been shifted to the more yellowish red, not the real red, because the real red has been cut out because of the filter. Maybe I think that's what I think. And this is the green spectrum of the green LED. As you can see, it is a little bit sharper than the clear green. I don't really know why as well. So there might be some science behind that. I'm not really sure about that, but at least we get the spectrum of each of the LEDs that we have set up. So I didn't use the yellow and the orange and the other color because of the limited resource of the LED at home. So I think in the future I might try to use it. And I also think of the use of various function, or trying to build a function in the Python in order to make it easier to identify the spectrum of these LEDs. And also I have also think of that I should use a method that that have a slit, and a very narrow slit to each of the LED, to picture each of the LEDs individually to avoid interference pattern, and also some sort of a broadband stuff happening around because of the LED zeroth order is not very sharp enough, I think. So I think I should make it even sharper in order to determine and having a better result of the spectrum. This brings me to the end of my video, I think. So thank you for watching.